So we're going to take some notes today on some basic logarithms. So a logarithmic function is the inverse of an exponential function. So what I want you to get out of this today is how to take an exponential equation and change it into a logarithmic equation. That's all I want you to be able to do. I want you to start seeing the pattern of how to change it from one to the next. We're going to get into graphing it and what does it mean and how do we solve it later. I just want you to look at the structure of how it's written and see if you can go back and forth between one to the other. So a logarithm, if we have b to the y equals x. So the idea is in a problem like these, we wouldn't necessarily know what the exponent is, and that's what we're trying to figure out. You can figure out what an exponent is by using a logarithm. So what we do is it's the base, which was our original base for our exponent, becomes the base of the log. So it's going to be log base b, that's how you say that, log base b, of x, so our answer goes over here, equals y. So what we've done now is our answer that we didn't know, like our exponent that we didn't know, becomes the answer to our question. So we're able to isolate it and get it by itself. So that's how the inverse works of an exponent in a logarithm. So a kind of more basic way of saying this is if you have your base raised to your exponent and it equals an answer, that's going to be the same as the log to the base, so that's where your base number goes, of your answer equals your exponent. So look at where everything goes. So the base in the exponential goes to the base of the log. Your exponent becomes your answer, and your answer moves next to where your log is. So we're going to practice a couple to see if we can go back and forth between them. And that's all I want you guys to be able to do. Look at the movement of where everything is and see if you can kind of see the pattern. Don't worry about what it means or what we're going to do with it. Just look at the pattern. So if my exponential equation is 4 to the third power equals 64, I'm going to change that to a logarithmic equation. So I'm going to start off with log. The log of, and it's going to be log base 4 because that's my base, of 64 because my answer goes there, equals my exponent, which is 3. Which means both of those answers are the same thing. Log base 4 of 64 is 3 because 4 to the third power equals 64. So let's try it with a log equation. So we have log base 5 of 1/25 equals -2. Within this equation, this is our base, so that's going to be our exponential base. This came from our exponent, so I'm going to put it back up in the exponent. And this is our answer, so I'm going to make it our answer. So log base 5 of 1/25 equals -2 because 5 to the -2 equals 1/25. So now we're going to get into just some ones with variables in them. So 2/3 squared equals y. So we're going to have log, and our base is our 2/3, because that's our base over here, of our answer, which is y, equals 2, which is our exponent. And log base 1/2 of m equals n. So our base for our exponential is 1/2. Our exponent is the n, because that's what it equals, and our answer is m. So what I'm going to have you guys do is I want you to try these 4 problems, seeing if you can move all of the stuff into the correct spot. That's all I'm asking you to do. Try to figure out the pattern of where the base, the exponent, and the answer go in the logarithmic, and where all the pieces of the logarithmic go into the exponential function. So see if you can do these 4, and then we will go over them in class, and I'll see how well you did. Okay. See you on Friday.